Welcome,
Okay, great.
everyone. This is the start of a separate meeting where we're going to discuss the work that Jeremy Freeman and Andrew Osheroff have been doing on the MyBinder project, which is basically the coupling of containers and runtime environments in Jupyter and TempNB for basically executable, reproducible Jupyter code plus data plus Docker. So let's get going. There's been a thread on the mailing list. We have a hackpad for notes, and then we'll post this recording afterwards, and we'll link it back to the mailing list. So let's go ahead.
Great. I guess I could start by saying just a little bit about sort of what led us to do this, and then maybe there's a way into some of the stuff that's come up recently, especially in the mailing list. The starting point really was basically TempNB. And the fact that for a couple of our projects, and those projects included both sort of software libraries we were developing as well as data we wanted to make available, we basically just used TempNB exactly to build little sort of private website environments for playing around with our data that we were sharing or playing around with code we were developing. And it was basically the process of doing that a couple times for a couple different libraries that led us to want to find a way to make it essentially trivial to go through the process we had gone through each of those times. And there was sort of separately a conversation I had with Matthias and Fernando in a bar at Berkeley where we had basically, Fernando had the idea of wouldn't it be cool for this kind of thing at least to be deployable basically straight from a badge in a GitHub repo. And it was really those two things that led us to try to build this. And then Andrew had the I think amazing insight to try to build it on top of Kubernetes, which is a new platform open sourced by Google recently as a way to deploy Docker containers across a cluster. That's kind of fundamentally what it's for. And put something together. We then put a demo together that we posted a few days ago on the mailing list. I think the response has been really cool, and it's generally working. We had to put out some fires after somebody tweeted about it because we quickly had to scale up well above what we expected. But we think we now have that actually went really well. It is the nice thing about this system is that it scales well. There's a ton of stuff still to be done. Kyle had some phenomenal points on the forum, on the mailing list that we're starting to talk about. I also think this whole process has brought up a bunch of more fundamental questions about, in general, how to containerize and describe and deploy these environments. Peter Wang from Continuum had a long bunch of comments that we're going to start jumping in on. So I think it's sort of there's cool stuff in place. We're excited to see where it can go. I think it brings up a lot of maybe even more fundamental issues about how to solve some of these problems and how to handle a variety of different use cases. There's sort of I have a repo and I want to turn it into a reproducible environment. Then there's like, I want to work on my workstation and just build a sort of arbitrary combination of Jupyter kernels and services. How do I do that? Then there's the sort of, I want to deploy a lightweight cell. This is really what Kyle's been doing such awesome stuff on. And that's sort of a different but related system. And yeah, we're excited to hear about other approaches, figure out how all this fits together.
So right now, just to help me, because I actually haven't had time to look at the
Sure.
at the specifics. Right now, where does it execute? On
Right.
what cloud environment does it execute? On Amazon?
Yeah. I'll jump in on this one. Yeah, it's all executing on Google's cloud right now.
On GCE. Okay.
Yeah, on GCE, but we were using AWS before, and the cool thing about Kubernetes is that it's pretty portable, so you can deploy it just about anywhere, and it'll generally work. We're using a few GCE specific features that we'll have to we'd have to figure out how to transfer elsewhere if that was something we were going to do, but it's a pretty portable system.
Okay. And whose credentials is it executing with? Yours or?
Yeah, it's with mine right now.
Right now, it's executing with yours. Okay. Okay.
Yeah.
So, because obviously, eventually, we'll need to make it so that it's the user's credentials that get executed that gets executed with, so that you can pass that buck over to the user, and it's not being done with your credentials. Because I think as we had discussed with Jeremy in that conversation at the bar, ultimately what we want to do with this is sort of create a marketplace where the cloud providers can compete on the back end on the services, and there can be a marketplace for them to compete on that, on access to the data, on access to the services, on the price, because that's kind of a race to the bottom, right? And the space where the interesting science, where the interesting development happens is the creation of the code, the creation of the runtimes, the access to, the creation of the scientific data, which is the kind of things that I know interests people like Jeremy, people like me, is where the scientific research, where the education is occurring, and the infrastructure providers are in the business of creating the large data centers, and hopefully that can create kind of a productive dynamic between the two. I think there's an interesting kind of, can we create the right incentives for this to be productive, and for this to break monopolies like the publication monopolies that I know at least Jeremy and I are deeply, deeply interested in using this as a torpedo that can be aimed below the waterline of certain monopolies that exist and that are very, very toxic in the scientific world. And I deeply believe that this is the right torpedo that can be aimed below that waterline.
Just to add to that, one of the other sort of inspiring use cases that happened in the last couple of weeks was a guy working in our group who had put together a whole bunch of both data sets, sort of lightweight data sets, some code, some repos, and this allowed him to basically, with zero DevOps experience, zero distributed computing experience, just put together a repo that now has the binder badge, and that is everything associated with his paper. It generates all the figures. And as far as we're concerned, like we may still go on to submit it as a publication, but we're done. Like that's it, and it's great. So I'm absolutely committed to that vision. I think with respect to the sort of who pays for it thing, we found very appealing, if it's possible, and supportable, that a way to have so right now everything's running in this kind of single node version, or not even single node, sort of single process. And the resources there are really not that enormous. We love the idea that somehow we could have a version of this where if all you want is essentially enough to do some kind of lightweight computing, not unlike TempMB, then that can be basically provided for free as a public service. But the moment you want to have more than one node, or you want to have a Spark cluster attached to it, that's when we find a way to sort of pass through to the providers, exactly as Fernando is saying. And right now you can attach Spark to your binder, but it's really just for testing, and all it runs is essentially one node. But the way Kubernetes works is that can be, it's basically a one change for us to suddenly let people start deploying 10 node clusters. We're not going to do that because that should not be a sort of public service. But if there's a way to pass through straight to GCE, AWS, we sort of don't want to be we need to find a way to do that where we don't actually have to manage anyone's credentials. I think that there's, we don't want to be things like user accounts. It gets complicated. If there's a way to sort of just, pass through and pass on the buck, that would be phenomenal. So we definitely want to try to figure out a way to do that.
Right. Kyle,
one thing
what are your thoughts on this? Go ahead.
One thing that I think is worth thinking about is if something like this could or should eventually replace NB Viewer. In other words, to move NB Viewer away from static content and just say notebooks are notebooks, and people usually will want to share them with live computation enabled.
So my perspective on the NB Viewer piece there is that we should continue to be terrible SEO grabbers and have static pages that get rendered, but that we can allocate the kernel on the page, as in it can reach out. So it could become a dynamic notebook, but the thing we serve is still a static notebook.
Gotcha.
So like you have to actively choose to switch over to a dynamic mode, which the same stuff for O'Reilly stuff. A lot of people aren't running the run button. They read through the content but don't actually run the code.
Interesting.
And so by not allocating the kernel until they click it, you don't have to spend the computational resources if they just wanted to read through. And then, of course, a lot of people will also, click through and run it.
Good point.
And I'm actually quite surprised that O'Reilly decided to default in the way they rendered their content on beta.o'reilly and on most of their pages, to render it without output by default. I was very surprised to see that's the route they chose, because what I would have done in their shoes would have been to pre-render with output, so that you only have to execute if you're going to change something, because right now they basically have to spin up a kernel to see any figures, right? Whereas
it's not that way across all of them. Some of them do have output. They have that configurable, but I think in a lot of them they've left them. But there's a way to, like with Thebe, you can choose to do that.
Okay. Well, maybe so. The ones I've seen, maybe the ones I happen to have seen have no output at all until you hit run on all the cells, which means that you have to force execution. Okay.
Yeah, so
go ahead.
I was going to say a long time ago, when the TempMB stuff started up, I actively resisted building Docker images and actively resisted pulling things from GitHub repos because I wasn't sure what the security story was going to be like for Docker yet. And I was like, we should only do trusted images. And so that was some of the design goals that were definitely not stated anywhere within a repository. But mostly because we need instantaneous on for the nature demo, because that's what it was created for. There was no extra thing beyond that. So I'm really happy, Jeremy, that you're trying it, because I know what else you can do inside the images themselves and everything. And that's why we kept locking more and more things down. And hopefully we're able to do that with Kubernetes, because I don't actually want to maintain lots of these systems. I just want to be able to explore new avenues with them.
Yeah.
So, yes. Jeremy, what is the persistence story with binders? Sort of, if I open up one of these binders and I run it, do I come back to it? Is it persistent? If I make changes to that file system, can I find it later? Or is it as ephemeral as a TempMB execution image?
So I think it's a little more persistent than TempMB. It definitely maintains, it gets called after a period of inactivity. What is it at now, Andrew? Like an hour?
It's an hour now. Yeah.
Yeah. But within, beyond, other than that, if you don't leave it inactive, then you can create notebooks, you can save notebooks, everything more or less persists. You can share the link. And it is basically your own environment. And, we don't I suppose we could impose something like if you've had it for 6 hours, then we just cut you off. But we don't have anything like that now.
Because this is another place where beginning to think about hooking it with some kind of persistent identity, so that you can, on the one hand, find a way to pass on identity and credentials and therefore pass on the buck of who pays for execution, frees you from that concern, but it also enables the person to say, hey, I started playing with this thing, but next thing I knew, I was doing real work. And now I actually want to keep that thing, right? I got sucked into it, and now all of a sudden I actually ended up working on this thing, and I don't want it to disappear. And I called in a colleague, and now all of a sudden we're working on this thing. Please, this is now my work, and I want it to persist because now I'm actually going to take it from here. And so you can see these things effectively becoming work, right? And so I want it to be basically to naturally say it's my repo, right? And it is my execution environment, and to have it show up as a fork on GitHub, and have it basically it's the natural execution companion to get to GitHub, right? GitHub gives you the source code. This gives you the execution runtime.
Mm-hmm. Yeah, that's super interesting. It also relates to one thing we've been doing a lot for the purpose of developing our examples, but it's, again, a pattern that we've gone through enough to realize we really need to find a way to do it better, is, once you've launched one of these environments, you start making notebooks, you sort of want to just dump what you've done right straight back into GitHub. And that's a very natural thing to want to do as a way to sort of persist the stuff that you're doing. And that's something that I think, especially in the context of something like a user account. I mean, the other case where that would be absolutely necessary, like if people are starting 10 node clusters, they don't want to start their 10 node cluster, be working, leave it for an hour, and then have the whole thing shut down again. Now, the launch times are such that that's not a huge problem, but it is sort of, if you've gone through the trouble of starting something that complex and maybe you've done some configuration, you may not want to wait or have to relaunch it every time. But then, of course, that means the resources are being used for longer periods of time, so it's more important for people to submit their credentials and stuff.
Yeah, and I mean, one of the things that GitHub has been good at is exposing these kind of gradual on-ramps. For example, you're logged into GitHub, you see a repo, you see a file, you can click on the edit button. And right there, on the web browser, you're editing a repo, and next thing you know, they say, submit a patch. And if it's something that you're comfortable making an edit to, because maybe it's a typo, maybe you're editing just documentation, maybe it's a file that you're comfortable submitting your changes to with a web interface, right? They will let you do it right there, and they effectively are doing for you all of the mechanics of creating a fork, making a commit, giving you the interface for a commit message, for all of it. They're doing all that for you through that interface, right? The problem is obviously right there, if those changes require, say, an execution environment to really validate them, all of a sudden, short of that repo having a good CI, which it may, if the repo has good CI, at least you might see when you submit the pull request, you might see whether the CI returns that the tests passed or not. That's about the only feedback you're going to get. But you yourself would not have easy access to you running the tests for that repo and whatnot. But with this idea, you can imagine basically this giving you that flavor of saying, now take me smoothly into execution, but for that you need identity, right? Because it can't be this ephemeral, it showed up, it's isolated, it doesn't connect to who you are. And so there's a need for something which is a little bit less ephemeral, where people can persist who they are and what their work is, and connect it back in a way that they can later continue working on it, because that's the beauty of it, right? In GitHub, you can show up with a friend's laptop. I mean, you could be at a party, log into someone else's computer and start, I'm going to fix this thing with a web browser, do a fix. But you know that later you can pull that repo onto your regular workstation and continue working, because that is a real repo that you can connect back to your normal workflow of Git repos. And so it's sort of closing that loop of persistence and execution resources that GitHub doesn't have, does require identity, but it's not identity, I think, that you want to manage, because, I mean, none of us is in the business of becoming an identity provider, I think, in this case.
Exactly.
And especially because here, it's not identity, it's bridged to identities. It's identity, there's the identity of the code, which at this point, I think GitHub has won the race. And it's also the identity of where people are going to run. And those identities, some people are going to run on GCE, some people are going to run on Azure, some people are going to run on Rackspace, some people are going to run on AWS, right? And those providers right now are in a huge race of, I mean, we're talking about companies that are each worth multi-billions or trillions of dollars, right? None of us are going to be competing with them. We're not in that business, right? And so obviously there's going to be multiple identities. And so the question is, can we create a way for this to be an intersection point, which I think it has all the right ingredients. The missing piece is the okay, Kyle is back.
No, great.
The missing piece is is persisting the identity and bridging the identity of the code with the identity of the execution in a persistent fashion across, where you're the middleman.
Yeah. It's an enormous vision. I love it. I think I wonder how much we could get away with just by basically leveraging GitHub's authentication and GitHub's identity. We are very right now integrated with GitHub anyway. Yeah. And there's a lot I think one can do to leverage. I don't know that API super well, but
I've explored that this last week.
Oh, great.
So I have one node for it too. It's at gatekeeper.tempmb.org. Not for temp, just that's one of the orgs I have certs on, so that's why I used it. Got it. You can do a full client-side application that uses one gatekeeper node that you run to do the OAuth stuff. You can do everything else you want, like within GitHub Pages. So like the main stuff for Binder can be there, but delegate to a separate thing.
Oh, awesome.
And so like there's this pros project, and I think Gitbook is doing the same thing, where it's really like all a client-side app, but all the GitHub interaction happens over happens within like you do the normal OAuth flow properly, and then you don't have to run a server for like your rich application, right? And so like
what was that? It was called Gitbook, you said? The example
Gitbook is one that used it. Gatekeeper is the project I'm using. I can link that in the. I'll just link it on the hackpad.
Great.
I guess we're missing notes there.
You probably, you're doing all that stuff in the client, but you wouldn't want to be pushing up data sets and stuff like that.
No. So it wouldn't be for that. It would be about
the notebooks. Yeah.
So you could break away your application. So yeah. So like I started putting together a JS bin like thing. So kind of like the share cell stuff, but it was code on the left and then an iframe for all the outputs. And then saving those to gists, just as a demo of the output area that was being worked on.
Oh, awesome.
So that would just connect to any kernel, but like it would just be a federated kernel service that gives you access to the kernels rather than standing up like your own kernel setup or whatever. It's actually just using like a tempmb node, right? And so if it could connect to my binder and if there was an API for it, and this is kind of where I would hope things would go anyways, is that you reach out to an API, either there's an unauthenticated context to reach that API, and it's like, give me whatever your version of a temporary no-auth version of a kernel is. So like the tempmb binder, just instant, here you go. And then the authenticated version, which is you pass credentials over to the service, and then it creates the kernel wherever you've requested with some spec. And Tim Head at CERN is interested in this too, and that's kind of like where I want to take things here soon. And that's building like API just around notebook pieces that aren't the full notebook, but that give you provisioned compute. So, yeah. And I'm imagining in that case you pass like a Docker image name, and that you'd be able to run some like prefab whitelist of images that you're allowed to.
You mean for the sort of the quick boot up, it would just be
a quick boot up one, then it would use that.
Yep.
Yeah.
And we could
so go ahead.
Oh no you.
So I was going to say that I feel like it would probably be good if Binder was broken up into at least two components. That build wasn't necessarily part of like the launching.
Mm-hmm.
So that you could run it in a setup that was like with a specific set of trusted images.
I see.
Yeah, I think that makes a lot of sense. We were talking, Andrew, about that it should be reasonably straightforward to have this sort of like pre-provisioned pool of images running kind of just immediately ready to deploy based on pre-specified set of images.
I definitely think so. I think going back to what we were talking about before, just with multiple sets of credentials, I also think that kind of maybe plays into another issue, which is if you were to pass in, say, some sort of if we were to manage multiple identities, if we were to manage both the GitHub identity and some sort of cloud provider's identity and pass that into a notebook, what is the right way to sort of interface with that and save data out or, update a repo from within the notebook as it's running? I mean, you need either some sort of a helper library or something to make the interface easier. And I think, at least in Binder, there are some other motivating factors for that as well when it comes to things like service discovery. Like if you want to find how the Spark service is running on your cluster right now that you can access, that also itself requires some sort of discovery mechanism or motivates some sort of helper library. So I guess the question is, what would be the ideal interface for that sort of a problem or for working with these things? That's something that we're kind of thinking about. I don't know if we've, really converged on any.
Yeah.
Yet.
Well, if you're talking about repos full of notebooks, maybe that's something that does belong as an extension out at the dashboard level and not in the notebook itself, because when you do a git commit, you're going to want to point to a bunch of files, right? And not just the specific notebook that you're working on.
Right.
I could see cases for both. Like Kyle was saying, the gist output is an incredible, near-term goal, right? Of just being able to create an anonymous gist
From
with a
your
basically unguessable URL. Yeah.
Yeah.
That's a great starting point.
Gotcha.
Yeah, well, we can start. I mean, we can definitely start trying to play around with pulling these two pieces of it apart and doing some testing with that. I think that's a fantastic idea.
So are you saying sort of one extreme is sort of the very lightweight reference image with a reference kernel that, say, you provide reference Docker images that are known, right, that say have the Python stack or the R stack or the Julia stack or whatever, that can be referenced with a stable URL, that have known versions of everything, and then those can be used, and you can effectively use them as microkernel services APIs and write a notebook. You can post a notebook gist against them, and then effectively it's NB viewer plus a run me button that would give you what Kyle wants, right? Which is static NB viewer, but with a run me button if I want it. Is that what we're saying here?
I think that's exactly what I'm understanding. I mean, this is sort of breaking off the current model is that when you submit a repo as a binder, and this is what Kyle was saying to break apart. Right now, when you submit a repo, it triggers a process that builds an entire Docker image. And that takes about 5 minutes, and then it preloads that custom Docker image on all the worker nodes. And then when you hit our current endpoint, it only tries to load from that set. And as long as that image has been built, it will load it and deploy it. And that's reasonably fast because we're preloading all those images. Mm-hmm. But yeah, this would be to say, have another endpoint where when you hit it, it immediately gives you one of a set of preloaded, predetermined, and predeployed containers.
Yeah, because for a few reference things, you could imagine like the reference SciPy stack with a lot of the known libraries, the reference R stack with a lot of even the reference Spark stack with at least the single node non-cluster version running locally with PySpark, Julia, etc. Those can be made available with known, and you know that, and you load them with a lot of the common libraries. Those images can be made available, and then you know that 90+% of the stuff that is out there is going to be using, say, in the Python world, Pandas, Seaborn, Matplotlib, Scikit-learn, NetworkX, Scikit-image, Cython, etc. You preload an image, a Linux image with all of the current versions of all that stuff, and you've covered 99% of the stuff that gets posted out there.
Exactly. Yeah,
and you update those every 3 months or whenever there's a major release of one of the big 10, and you're done.
Yeah,
exactly.
This is something I'm interested in the high level stuff, but I think the implementation details of the Docker image building and how the notebook server integrates with those through the kernel manager is a pain point right now for everyone. And I was talking more with Kyle about this yesterday, and trying to get away from a Docker image per that includes all kernels to having kernel specific images that are much lighter to weight to maintain and have only a single kernel in them. And I think those, if we can build that infrastructure to allow that, those images can be the base images for all of this stuff. And then it's a very small amount of changes on top of those base images to do all the custom builds you guys are doing now, et cetera.
Right now, we really just have a single base image that is just has a Python 2.7 kernel in it, and it's probably a little larger than it needs to be. So yeah, I think trimming those down and adding a wider variety is definitely something we should put on.
But for example, it won't be long before people come along and say, hey, I want to use Binder with this repo over here, and I have R, Julia, and some other kernel. And then another person comes and says, oh, but I have Python, Julia, and it's horrible.
Yeah. And I mean, right now our response is just, you have to write your own Docker file in that case, and then we'll support it, but it's really not ideal. So
allowing companies.
And there's one example out there.
Go ahead.
Oh, I just said there's the example now. One of the examples that we have in the repo is a version that does add a Julia kernel, but it does it by basically just appending. It includes a custom Docker file, which just adds about 4 lines to add the Julia kernel. It would be much nicer if in the web UI, when you're configuring your binder, you basically say, I want to have the base kernel be this or that.
Yeah,
much better.
Yeah. And also, I'm very interested in seeing how the work in these temporary notebook projects can also affect and improve the deployment situation for Jupyter Hub. And I think moving Jupyter Hub also towards a similarly designed Docker-based deployment structure.
Oh no, I mean,
in a Jupyter
this
Hub
would be lovely. Yeah, imagine. I mean, what you want is effectively just as much as the new notebook, the new kernel is a menu for the user at the notebook level. Like when you're in the notebook and you say new notebook, it's a menu depending on the kernels you have installed. What you actually want is when you're putting it together, you want a menu. I want the kernels that go into the thing that I'm going to end up using. This is the menu of available things. This is my menu. This is the menu that Binder offers, right? I mean, sure, you can put together by writing by hand, but you could imagine a searchable, these are the available Python ones, these are the available R ones. You can search by criteria, right? And it will tell you which libraries each one has installed by versions and whatnot, right? And so you can search, you can filter, and then that's it. You populate the one, and then that's it. It drops in the kernels you have, and then it literally populates it with the kernels you have, and that menu of images is the menu that will be visible to the users when they're inside of it, right?
No, we're totally. I mean, actually, it seems already that's definitely a great target for us right now, because that will both start to get us towards what Kyle's describing by having basically splitting things out so it's easy to spin up something with each of these different, more modularized base kernels or base images. And also, we can basically then just build that menu in directly to the front end. There's no reason we can't do that.
Yeah.
We'll have to figure out composing things. Oh, go.
No, go ahead. I wasn't saying anything.
Who was talking?
So someone said compose. So I love what Docker has done with Compose, in that you can take something, you can run it on your desktop that is a complex, professionally configured individual pieces that you put together into a more complex whole but you can act relatively confidently because you know you're using this trusted build of Spark and this trusted build of MySQL and this trusted build of this other thing. I don't know enough about integrating the kind of metadata that you gather with Compose into Kubernetes. Has anybody looked into that? I mean, is Docker Compose YAML not a good thing for this kind of stuff? Because it sure looks like it does a lot of the things that you're talking about, right?
I think that Docker Compose and Kubernetes sort of address very similar issues. Kubernetes is basically just a way of scheduling pods, which is a set of interconnected containers in the same way that sort of Docker Compose would organize and orchestrate a set of interconnected containers.
Kyle, do you know if Docker Compose plays well with Swarm?
Yeah, I mean, because Docker Swarm is native, you can just use Docker Swarm. I mean, you can use Compose directly, and it'll set it up. Yeah.
Is Jess using Docker Compose for her Jupyter Hub stuff?
Nope. Because you don't normally use Compose in production. It's more like what you use locally for dev. And maybe I'm being unfair here. But there are more tasks than Docker Compose can actually orchestrate for you. And in the case of like Jess's deployment, there are specific things to run on the host system that need to be done, and so those are done in Ansible. And so doing the rest of the Ansible setup with Docker is like trivial. Yeah.
Okay.
I mean, I use Compose, but I certainly don't use it for deployment.
Right. I mean, it's I mean, you talk about an on-ramp, you know, it's already namespaced to everything that's out in the world, but lets you do the local things. It automatically builds you an individual one, but you can scale with it. It already, I mean, I guess it doesn't do anything in particular special in terms of the links, but it's a little bit prettier to set up the links in that compose file than at the command line. So I don't know. I don't have a lot of horses in this game. I'm interested in, I mean, we want to be putting these buttons on NBViewer, right? Like, that's the exciting thing to me. But thinking about how, so on the other side of this, when you get to that badge, a very, very powerful thing would be download this, right? I mean, you know, it's going to be a couple gigabytes, but hey, you want to bring this offline and you want to put your actual private data into it. You know, if you created something that would help somebody understand their taxes or something like that, no one's going to put their taxes up in the cloud. You know, no one's going to do that. But if you can bring down that thing locally and act a little bit more, you know, autonomously, you'd get all these same benefits, but it would be a little bit more trustable, right? People would be a little bit more welcome to do that with their own personal data. And I think that's a transformative thing too. You know?
Oh yeah, these images and these containers, I mean, they should be fully loadable anywhere. The fact that you're running them in the cloud, it just happens to be an accident of the implementation. You can run, and it makes the zero install process that much easier. But obviously, do you want to run this locally? Here's how you do it. You pay the price of a download. And I imagine, I mean, eventually it should be possible also to describe, these are the things this image is running. You may have those dependencies locally, or if you basically just describing what does this image have, because you may have those libraries, so that if you're running this locally, then you just clone this repo and you can execute it locally.
Well, that was Peter's point. Yeah. So he was like, why not Conda? We can have all of these things natively that we packaged natively. And you know, there's a few points here where native can answer the mail, but as you get to these more complex cluster looking things, I mean, it would be crazy to try and set everything up locally. That's why we have all this stuff. You know?
Yeah. No, I do think there's a lot of. Go ahead, Brian.
The reason I'm asking about Compose is I want to have us try to start building deployment building blocks that can work both across different cloud providers as well as local deployments, but also for deployments of Jupyter Hub or as well as the TempNB stuff. And so I'm trying to understand what the different tools are at the different layers and how we can abstract out the provider-specific APIs and where we do need provider-specific things and layers in that whole architecture.
So yeah, right, Andrew, you can probably answer. Right now, there's nothing provider-specific about the way we've done this on Kubernetes so far. If you were any of the images that we built, in addition, can be pulled down and then run locally with Docker. There's nothing that stops that. Peter was pointing out that people don't like to use Docker locally and that it's too much overhead, and that's a different issue. I don't know exactly how I feel about that. But what about the services? Can you pull down one of the images we build and then run the services locally, like the Postgres or the Spark? That's a different story, right?
It's a different story. So in terms of cross-provider portability, like I think that's pretty well addressed by Kubernetes. If I think in terms of the local case, simple binders will work fine. If you just have a single container, for example, that just has a set of pip or conda dependencies, then sure, that's fine. But yeah, as soon as you start integrating a bunch of extra services, then it gets more complicated, and we'd have to find some way to do that.
But I don't think we need to solve all the problem. I mean, as Nick was saying, the moment it starts looking like basically like a little ISP in your house, then the notion of doing it natively is not like, okay, you're running a Spark cluster and a Postgres server and a bunch of Unix services. Sure, doing that natively with pip ain't gonna cut it, right? pip install Postgres and running things on a local VPN. That's just not gonna cut it with a native install, and that's okay, right? And that's totally okay. At some point, there is a reason for running a bunch of things that are designed for running Unix, basically Unix tools, right? I do think that the idea of what Peter is saying has a lot of merit, right? That if we can build things that provide some of what people are doing with Docker-style tools, with more lightweight native tools for many use cases, I think that would be great. I mean, I do think there's a lot of merit in that, and if we can make progress with Conda-like tools even further, that's fantastic, right? I don't think that's a bad idea. But in the meantime, I think we should continue forward with this.
So I actually have to run in a few minutes, and I know Kyle wanted to have some technical discussions, in particular around the security stuff. But I'm wondering if one action item from all this would be for someone to start working on a Docker-based kernel manager to allow us to start to move towards this vision of a single kernel per Docker image. And part of it is a question of if this is something we should do at all, and then there's a second question of, okay, if so, then who has spare cycles to start to work on that?
I also have to run, and so I wanted to identify, are we converging on what the next steps are? Does it seem to be that basically trying to say coupling the assembly of the binder on the back end, where you assemble things with kernels so that those kernels that get assembled are the kernels that the user would see, is that the target that we want? Because that seems, and that would go in the direction of what Brian just said, right? And then the technical implementation of that would be, do we want to do that as a Docker kernel manager? And would you guys want to try to tackle that?
Interesting. Yeah, I mean, I guess what I was sort of imagining for this was not necessarily a kernel manager, but a set of specified, I guess, sort of images that describe the different kernels, but in a way that would be straightforward to kind of, in a way that was set up so that each could be launched independently, but also they could be combined. If, say, for example, during a binder build, you wanted to specify that you want, say, Julia and R and Python. I don't know, Andrew, what do you think about to do that.
Yeah, I mean, I think that maybe the image or the container that we launch could probably, with some pretty small modifications, expose, or well, it could at least serve as the foundation for exposing some sort of a kernel API for that particular kernel that's installed in that base image. And just by adding new base images, you both get a lot of kernels to choose from, as well as like full notebook support for those kernels like within the current.
But this is I want to clarify this point. Like the thing that we want to move towards is that there is never more than one kernel installed in a given image.
Right. I think. I mean, even with that, I mean, I think. I think it's certainly
R and Julia. It means that when they open the notebook and they select between R and Julia notebooks, each of those kernels runs in a separate image that is completely separate and may not have a common base.
I see, but you still get the selection between these kernels from the notebook front end. I see. Okay.
And the problem is, otherwise you have this combinatorial explosion of how do you compose Docker images that increases your build times, increases the image sizes. It is a very painful difficulty.
Totally. Yeah. I mean, I think that then maybe a good step, would be to just split up the current image and extract out sort of some of the notebook side stuff and just launch, a thin maybe. Yeah. I mean, I don't know if I guess the question is, what would, a Docker based kernel manager actually look like beyond just having a bunch of very lightweight kernel images scheduled on the cluster, or like launching, the 10 most popular n instances of the 10 most popular kernels on the cluster, and then just dynamically launching notebook images whenever we want to interface with them. Is there something sort of beyond that you think would be the right approach?
Honestly, at that point, I think it's a question of sort of the technical details of the kernel manager and the kernel specs and how those play with Docker.
So the reasons that I've not wanted to touch this yet, and every time we talk about it, is that it's the file system that's around the Docker image that's hard to deal with, not the fact that you can break out the kernels. Because I'm already using kernels like as a service right now. Because you just ignore the rest of the API, and all you have is the kernel's API. You don't need everything else. You just assume that kernel exists with the kernel spec you want, and then you have it. I even broke out a separate package that was just kernel service. But the hard piece is the file system, and that's going to be in terms of if it's a local application, can you get access to those direct ones, and do you have an opinionated flow for getting them to what volume do you mount in to present to those kernels so you can do normal POSIX operations?
Right.
Yeah, and so to me, more of the work that I think needs to get done before building the kernel manager is actually just around that outer API and breaking apart the services before we go whole hog into giving people Docker environments. Because so in my imaginary vision for the future, the notebook is a client-side app written in Electron with Kitematic, and it just uses this kite shell. And all your kernels go out to Docker. When you install, you can select from a bunch of different images, which might even be an image from your friend, a colleague, whatever. It has a kernel end dependencies and other things for you. But then it brings in your local storage, and you can just go ahead and work with the notebook right there. And then you're not running a server technically you're not running a server through this, because VirtualBox is holding all the images, and then the users don't have to worry about Docker. So a given data scientist doesn't have to worry about Docker. But to me, that's a long thing down the road.
Yeah. No, and I should clarify. I have a very specific deadline I'm up against, and that is a very complex Jupyter Hub deployment with probably 10 different kernels Spark by January 1st. And to me, the file system thing is going to be solved by a shared NFS file system. And I agree, Kyle, that is something we have to solve.
The nice thing about Docker, and why you don't have to worry about it, even though I know it's taking up more space and is more difficult to deal with the Docker image, is that once users are sharing that same image, it's the same 2 gigabytes, 4 gigabytes, 6 gigabytes, it doesn't matter because it's a layered file system. So if you have 200 users, they're all using that same base setup. And so it doesn't matter. I mean, that's exactly why Try Jupyter is working well. Like, it doesn't matter that our base image is 8 gigabytes. People may complain about it if they try to use it, like as in they try to pull the Docker image and work with it. But when users get to it, it's there because it's the same file system. It doesn't matter. For your deadline in January, I would not worry about, like, because there are so many other pieces to solve. I think it would just make things really difficult in Docker land because volumes are probably one of the trickiest parts of Docker right now.
Yeah. I should say
I'm not trying to dissuade your idea, but if your deadline is January, I would definitely not recommend trying to get this working.
Yeah, I don't. And to me, I mean, part of like the usage case that I'm optimizing for is the many people right now, universities, who want to deploy Jupyter Hub, and they're not sysadmins.
Yeah.
Yep.
Like they don't want to build a Docker image for their kernels.
Yep.
They don't want to know that thing exists. And
yep.
I feel like I live in both of these universes. I live in the universe where I'm willing to write code and be a sysadmin and DevOps person, but I'm also a professor that just needs something to work so I can teach. and so I really want to push us towards having completely canned images for each of the main popular kernels that people at universities can pick and choose from when they go to teach a course.
Yep.
Rather than having to say, oh, I need to start to build.
Where we can literally say, here's Jupyter Hub, and here, you're going to teach a course. We're using Jupyter Hub, install Jupyter Hub, and here's the kernel that provides the SciPy stack, the R stack, the Julia stack, the Spark stack with PySpark and R and Spark R. Here, grab them, run them, and now all you have to do is give this to your DevOps people so that they deploy it on your university cluster and decide how many students you have and whatever. But these things are canned. Your DevOps people don't know the first thing about Python and NumPy and scikit-learn, but that's fine because you're giving them these things that are just wrapped up and ready to go.
Yep.
Because they're not going to go building scikit-learn or anything for you, right? They just want to drop these things into the campus machines and run them for your students. That's all they're going to be willing to do.
Yep. And that's why to me, like whoever gets on the admin panel, like if they can just select the images as kernels.
Exactly.
Yes.
Yeah, that's the experience that we want.
So
just like the students say, I'm going to do now, my professor told me to make an R notebook, and tomorrow we're doing a Python notebook, right? They're willing to say, assemble the thing with the R and the Python and the Julia thing for this class, and then this other professor is teaching Spark and R, and this other professor is teaching numerical methods in Julia, and this is what they're doing, right? They're just assembling these things.
Go ahead, Kyle.
Yep, no, that was exactly it.
And I know that usage case is very different than the binder usage case. I just want to make sure that if there's common building blocks, we can work across that address both of these spaces that we leverage.
But I don't think it's ultimately that super different from the binder usage case in the long run.
I think it's similar, and a lot of it could come down to sort of where it's being deployed. I mean, at least right now, I don't know what it would be like to. So you're describing deploying these more sort of university targeted things on university cluster compute infrastructure.
No, probably in the cloud using Kubernetes or Swarm, or I mean, really similar to what binder is, honestly.
Yeah. No, I mean,
go ahead.
Oh, just it definitely seems then, because so getting something like Kubernetes set up on a university cluster, that's a process I am scared of. But just having dealt with getting a lot of weird shit set up on university clusters, it's not been the most pleasant thing. Things like Spark and whatnot. But if it was, if it can be cloud deployed, then I do think there's a ton of overlap and the improvements that we can try to make over the next next month, next 2 months would hopefully help in what you're describing.
No, and obviously the focus of the conversation with you guys is not to drag you into that tar pit. With you guys, it's obviously Binder is in the cloud, and that's where it should stay, and that's what you guys are working on. But we're trying to understand what of the work you're doing can help us improve what happens in Jupyter Hub, because a lot of Jupyter Hub is going to end up deployed in the cloud. Let's be honest.
Right.
Netflix just shut down its last data center, right? Universities are going to be deploying a lot of this in the cloud as well. Some big universities do have their own data centers. Many do not, and fewer will as well. And so a lot of this is going to end up deployed in the cloud as well. And for me, and the more this infrastructure is ready to go in the cloud, the easier it's going to be for a professor actually to say, especially at universities that haven't bought into this idea campus-wide. Like at Berkeley, because of what Jess did, and because I'm here, and because of what is happening, we have a place like BIDS. There's a campus-wide initiative on this stuff. Yes, campus is buying into this institutionally, but at many places, you may have one faculty who believes in these things. If they don't have institutional support, they may be willing to say, I'll pay maybe out of my grant or out of whatever, I'll pay a cloud account to teach my class this semester, and what they can do, or they get an educational Amazon grant or whatever, right? They may be able to fund one semester's worth of one class in the cloud to do it. That will be possible if we provide the building blocks to do this in the cloud.
Easy way to make it happen.
Yes, if we provide the Binder equivalent of deploy this in the cloud, they have their credentials, they set it up, we make this happen, and then this thing and you've seen the threads on the mailing list about people deploying Jupyter Hub all over the place in their own ad hoc ways in educational clusters. If they can do the same thing with their credentials in the cloud, this will begin happening like wildfire in education worldwide.
Yeah. And Kyle, I hope you understand, I completely buy into your vision of separating out the services from the front end code. That is something we absolutely need to do. And
yes, it makes sense for both Jupyter Hub and the local thing.
Oh, absolutely. And so I don't think anything we're saying here goes against that. I think you're right on in that vision.
Okay, so folks, I have to run to another meeting, unfortunately. But this is incredible. I'm extraordinarily excited about where this can go in so many ways. And thank you so much. And Andrew, it's a pleasure meeting you. And if you're ever in the Bay Area and the West Coast, please drop us a line, and you're more than welcome to stop by. And Jeremy, I'm sure I'll catch you again in person sooner rather than later.
I'll be there, in mid-September, and Andrew and I we're going to come to Strata, so we can meet up with this NYC Docker crew, I guess, that's going to assemble.
Right. Okay, cool. We'll see you at the workshop here, and then you'll see the crowd at Strata again.
Excellent. And we'll start looking into what integrating things like, the sort of Jupyter Hub Kubernetes combo. We can definitely start looking at that.
Okay. And also, Kyle and Jeremy and Andrew, if you guys want to keep talking about the security stuff, please continue. I have to run off to a meeting as well.
Awesome.
I think Fernando and I would be lost in the details of that, the security stuff anyway. So
we'd love to talk more, Kyle. Are you game? Hang around. Awesome.
Cool. Good.
Okay.
All right. Nice to meet you guys.
Bye, guys.
Okay.
Sure.
See you, folks. I need to stop the recording because otherwise it would go on for forever. Actually, because I have to run to a lunch meeting. Okay. So see you guys.
Yeah.
Bye. Thanks.
Howdy.